All right. So investigating parabolas, we already have worked on the parent equation. And again, I apologize that we had such a crazy morning. So we already know the apparent equation of y equals x squared. Remember, if we rewrite that, it would look like this. So our vertex would be what? The same thing you just did on your show. So what's your vertex be? 0, 0. Which direction would it open? It's a y equal, so it's either up or down. And it's up because it's positive. Same thing on the next one. If you have the negative outside, we're just going to rewrite it as negative x plus 0 squared plus 0. So what would your vertex be? Same thing, 0, 0. But your direction would be what? Down. All right, let me minimize this so it's not in the way. All right, so example number 1 says, here's an equation that may look a little different, but it's not. So you have the 12y squared, or 12y equals x squared. Remember, whatever squared is going to tell you what you should solve for. So we want to solve for y because it's not squared. So the way we solve for y is divide by 12. And we get y equals 1/12 x squared. But remember, we can rewrite that like above, that 1/2, or sorry, that 1/12 comes outside, x plus 0 squared plus 0. It's just getting you to look at it as it's already in vertex form. Don't think that it's any different. So what's your vertex on this one? 0, 0. What's your direction? Up. Very good. All right, so it says, what is the A value and what does it do? The A value is 1/12. Now remember, it tells you whether it is fat or skinny. And then it also tells you the direction. Okay. So the actual number tells you whether it's fat or skinny, whether it's positive or negative tells you the direction it should face. All right, so number 2 is exactly the same way. We need to get this y by itself, so we're going to divide by negative 32. And our equation is y equals negative 1 over 32, x plus 0 squared plus 0. What's your vertex again? 0, 0. And then this time, what's your direction? Down. Again, what is the A value and what does it tell you? On this one, it's negative 1 over 32. This tells you that it opens down and it's fat, or a vertical shrink squishes it down. Any questions so far? All right, so now the harder part of these notes, and they're not that bad, I promise. We're going to start writing equations. We're going to talk about directrix, focus, focal length, and endpoints, and they're really easy when it's like 0, 0s and stuff like that. One of our last set of notes gets a little harder. This is all we're doing pretty much all the rest of this unit. All right, so if you don't get it today, you have Monday, Tuesday, Wednesday, you'll get it, okay? So relationships among certain features of parabolas. I'm only going to use one of these. I don't need both. So there's one thing that I want to point out here, and that's called the focus. The focus is the same distance from the vertex as this line down here, and I tried to make it dashed for you. This line is called the directrix. Remember this line down here, this dot down here is your vertex. We already knew that one. And it's not going to look like it because of the way that I drew it. But the distance from the focus and the vertex and the focus and, the directrix and the vertex are the same. So we're going to call that C. Those distances are always the same. And then you have what are called focal chord endpoints. Focal chord endpoints. And those are twice the distance. None of that's really going to matter to you at this minute because you don't know what those things are, but it just gives you a visual. Okay. So it says, as you can see, the C value is very important. It's called the focal length. There are several relationships built around the C value, and the formula for finding C is C equals 1 over 4A. So you definitely need that. So let's go back to example 1 and determine the C value. Once we know the focal length, we can find everything else we need. So example 1, we found that equation to be 1/12 x squared. And then in the very top, we know that that 1/12 is going to be our A value. So to find the C, we do 1 over 4A, which is 1 over 4 times 1/12. 4 times 1/12 is 1/3, and then it's flip and multiply or just 3. But you can do that in your calculator. I don't have my calculator up here, it's up there. But just understand that it's 3. So C is going to be 3. You will do 1 over 4A a lot. Okay, a lot. So if you don't have a calculator, you might want to get one. All right, so it says graph the parabola x squared equals 8y. Find the graph and find and graph the focus directrix and focal chord endpoints. You will have to graph those. It'll make it easier if you do. So the first thing that we're going to do is we're going to make this equation correct. So I want to solve for y. How do I do that? Divide 8. And then I'm just going to rewrite it up here so you guys can see it. It's going to be 1/8 x squared. But remember, we can rewrite that as 1/8 x plus 0 squared plus 0. And I want to keep writing it like that because eventually you're going to get a different vertex. So right now, all our vertices are going to be 0, 0. I'm going to add a couple things up here. We're going to talk about the vertex, the axis of symmetry, which is what you did on your test, and the direction. And then the new stuff that we're doing is focus directrix and focal chord endpoints, and they're really easy. So what is your vertex for this one? 0, 0. What's your axis of symmetry? If it is y equals, remember your axis of symmetry is x equals, and whatever the x coordinate of the vertex is. What direction is this one? Up, down, left, or right? Up. It's y equals, so it's up or down, and it's positive, so it's up. All right, so once you get those, it makes it a little bit easier. The first thing that we want to do is find C. Find C. Remember that C equals 1 over 4A. What's your A value on here? 1/8. So 1 over 4 times 1/8. If you put that in your calculator, you get 2. All right, so here's how you start graphing. Your vertex is at 0, 0. Your C, remember, is the distance from your focus to your vertex or your directrix to your vertex. So up to and down to. And how do I know I go up and down? Because our parabola opens up or down. That makes sense? Okay, we'll eventually do left, right ones. But right now we're just focused on up and down. So up to and down to. One of those is going to be your focus, and one of those is going to be your directrix. How do you know which one's which? The focus comes inside the parabola. So if you have one like this, a parabola that's U-shaped, your focus is inside, your directrix is outside. If it's upside down, your focus is inside, your directrix is outside. So which way did this one open? It opens up. So if I kind of, you please don't sketch this, but I'm just doing it in pencil so I can erase it. So if this is what it looks like, this point is going to be your focus. So your focus is at 0, 2. Again, how did I get that point? I plotted the vertex and went up 2 and down 2. The other one is your directrix. And it's a dashed line because it's not really there, but it is. So it's a boundary that's not really there. How do you know what you write for the directrix? What axis does it go through? It goes through y, and it goes through y at -2. The last thing you want to do is find focal chord endpoints. Remember that your focus was C, your other line was 2C. So focal chord endpoints, you're going to do 2C. C was 2, and 2 times 2 is 4. So from the focus, you're going to go 4 to the left and 4 to the right. So I almost made that thing perfect. So we went 4 to the right and up 2. 4 to the left and up 2. So those 2 coordinates on there. And that's it. That is it. All right, so the next one is the exact same thing. It just opens a different way. So remember, we want to find our vertex, our axis of symmetry, just to review those, and the direction. We're going to rewrite this one by dividing by -6. So there it is in vertex form. The 3 things that I added, you should already know from the last chapter. What's your vertex? 0, 0. Axis of symmetry. Remember, if our equation is y equals, our axis of symmetry is the opposite, which would be x equals. And then it is the x coordinate of the vertex, which is 0. What direction does this one go in? Down. The reason we need to know the direction, remember we start at the vertex, and I'm just going to sketch it real quick. The focus goes inside, the directrix goes outside. Okay, so that's why we need to know the direction. We're going to find C. Remember, C equals 1 over 4A. What's A in this problem? Which actually gives you a value of 1.5. You can put that in your calculator, just trust me on it, but it's 1.5. Don't make it complicated. It only gets complicated when we move our vertex from 0, 0, okay? So this is just as easy as it sounds. We're going to go up and down 1.5. Up and down 1.5. The focus is inside. The directrix is outside. What is that focus point? I went over none and down 1.5. Your directrix crosses the y-axis at positive 1.5. We're going to find the focal chord endpoints by doing 2C, which is 2 times 1.5 or 3. So from the focus, I go left 3, and sorry, I went too far, and right 3. those coordinates, I went right 3 and down 1.5. I went left 3 and down 1.5. And then if we were to sketch it, we just connect the dots. I don't necessarily need to see the sketch. I just like having the graph so that I can physically put it on there, see it. All right, so that's what you're going to be doing a lot of in your homework. All right. Number 3 wants you to find the equation. You'll be doing this a lot as well. So for the parabola with a focus 0, -2 and a directrix y equals 2, use the formal definition of a parabola to derive the equation of the specific form. You don't have to work really hard on these. So all you need is a little bit of graph paper. And if you guys need these, I'll get those. There's graph paper up there. We always have graph paper. So if you're at home, I've asked you to get graph paper from the beginning of the year. If you don't have any, print some off or make your own. It's harder if you make your own, just being honest. All right, so we have a focus at 0, -2. We have a directrix at y equals 2. This tells you 2 things. The first thing it tells you is exactly where the vertex is. And the second thing it tells you is how it opens. Okay, so how do I know where the vertex is? If I go back to these, here's your focus, your vertex, your directrix. Focus, vertex, directrix. Where is the vertex compared to the focus and the directrix? What kind of distance? Yeah, it's equal distance between, so it's halfway between, right? So if we're looking at this, what point is halfway between that directrix line and the focus? 0, 0. So here's our vertex. Is everybody good? Vertex is 0, 0. All right. So this is what we have. Y equals A times x plus 0 squared plus 0. Which way will this open? Yeah, we know that it's going to open down because the focus has to be in it. So our A has to be what? Negative when we finish. Okay, so that's the big thing you need to watch out for. All right, so then how do we find A? The only thing we have is we need to find A. You remember this formula? C equals 1 over 4A. That's how we're going to find it. We know what C is. Remember, C is the distance right here. How far is it? How far is it from those two? It's 2. So C equals 2. So 2 equals 1 over 4A. This is an equation that I can solve. I can set it up as a fraction where I cross multiply. I get 2 times 4 is 8A. 1 times 1 is 1. We're going to divide by 8. And A equals 1/8. But what do we need to remember? Which direction does this open? Down. So when we rewrite it in our equation, it needs to be a negative 1/8. We have x plus 0 squared plus 0. Or you could have just written negative 1/8 x squared. Either one of those are acceptable. I would like you to keep the 0 zeros in there just because of what we're doing later on. All right. So this is not a lot of notes. Your homework looks exactly the same. Keep your notes out and follow through that. Zoomers, I am finished. I'm going to stop sharing, stop recording. If you have questions, ask me.